pHs, we can use universal indicator. So this is hydrochloric acid, and I'll just put 4 drops in. It's quite a pink colour. If we look at the colour chart, yep, we're going to estimate a pH somewhere around 3. Now the next one is acetic acid. These are all a 0.1 concentration. So acetic acid is a weaker acid, and you can see its colour. Maybe we'd go to a pH 5, but it is a different colour, but it's not very easy to tell apart. The next one is water, which should be neutral. Yeah, it's neutral-ish. It's probably 6.5. Now the next one is ammonia, which, as you know, is a weak base. So that's giving us, again, it's kind of hard to compare it to the colours on the colour chart, but it's giving us a bluey kind of colour. And then sodium hydroxide, which is a strong base. Still giving us a blue colour, should be a different pH significantly, and you're not really able to tell that with indicators. So the bonus of a pH probe is that it's going to give you much more accurate values. So here is the pH probe. We do need to rinse it off between everything we do. So I'm putting it into hydrochloric acid right now. And I'm getting a value, it's a bit wobbly, but it's about 1.4, which is lower than we would have been able to tell from the colour chart of universal indicator. Now, if I put it into acetic acid, it's just about 3. So you can see its pH is higher, even though its colour wasn't notably different. This is into water. Let's hope we can get it, keep going up to neutral. Or not. Okay, I might try that water one again.
So sometimes what happens when you use your probe, you get a little bit of the acid or the base left over on the outside of the probe, and it's disrupting your next reading. So this would be a time when, if it's still not giving you a pH of 7 or close to it, you'd be looking at stopping and recalibrating your pH probe.
So it's getting up towards 6, and I just use tap water then. And tap water will often be a little bit more acidic than distilled water. So yes, it's close to neutral, but it's not perfectly neutral. I'll make sure I do give it a good rinse. Okay, so we're now going into ammonia. So 10.6, close to 10.6. And finally into sodium hydroxide. Which is giving us 12.6. Now, that is significantly more accurate than the colour chart. The colour chart doesn't distinguish between whole numbers, and remembering that one whole number is a factor of 10 in pH, that's a lot more accurate with the pH meter.